one, separation of miscible liquids. Miscible liquid means two liquids mix each other. For example, acetone in water, ethanol in water. This type of mixture we can separate by this method. It is distillation. We will use another term, distillation, to separate miscible liquid. There are two different types of distillation. Distillation means the process by which we will separate miscible liquids. Miscible liquid means two liquids mix each other. Example, alcohol in water, acetone in water. Okay, so this type of mixtures are miscible liquids. Okay, so here distillation. There are two types of distillation we will discuss, simple distillation and fractional distillation. Simple distillation and fractional distillation. These are the two different types of distillation. Okay, so let us see here, this is the apparatus used for distillation. For distillation we will use a special type of flask, round bottom flask. Bottom part of this flask is round shape. That's why we will say round bottom flask, RB flask. Okay, or we can say distillation flask. Also we can say distillation flask. So we will take the mixture in this flask. We will take the mixture in round bottom flask. Okay, and we will heat the mixture over here. We will heat the mixture here. Okay, after heating mixture, we discuss here immiscible liquid mean two or more liquids, two or more components. So components with a low boiling point will change to vapor. Component with a low boiling point, it will change to vapor. And this vapor will come over here. This apparatus is called condenser. This apparatus is called condenser. Okay, so after heating, the component with a lower boiling point, it will change to vapor, and this vapor enter in condenser. Okay, in condenser it is a special type of apparatus. It used for cooling. To cool the vapor. Okay, after cooling this vapor, again we can change back to this vapor into liquid state. Okay, so liquid acetone or liquid alcohol, the component with the low boiling point, again it will change to liquid state. This way we can separate miscible liquid. So here this is condenser. Look here, this vapor will come here. Here this is one apparatus. Inside there is a tube, inner tube. Inside that tube there is vapor. Outside there is a covering. Okay, through this covering we will pass water. This here water in and here water out. We will pass water through the condenser here, and water will be outside. We will collect water outside here, and this water helps to cool vapor inside the condenser. Condenser used to cooling. We know after heating the system gain energy. Sometimes you have the question, where this system gain energy? Here in RB flask, system gain energy because we heat over here. Where this system losing energy? After cooling, the system lose energy. We cool over here, the condenser cooling. So here in condenser, system losing energy. Okay. So this is also here we will keep thermometer here. This is thermometer. This thermometer helps to control temperature. We heating over here. Okay. So to control temperature, we will note the temperature over here in the thermometer. For example, we have the mixture which contain water and alcohol. Alcohol will boil at 70 degrees Celsius. Water will boil at 100 degrees Celsius. So we will heat over here and we will maintain the temperature around 80 degrees Celsius. Around 80 degrees Celsius. Clear? So around 80 degrees Celsius, water boil 100. Alcohol 70. So at 80 degrees Celsius all alcohol changes to vapor, but water stay over here. At 80 degrees Celsius, water did not boil, it need 100 degrees Celsius. So water changed to alcohol changed to vapor, and this alcohol vapor will be condensed by condenser, and we can collect alcohol over here. This method is called distillation. Okay. So also I told you there are two different type of distillation, simple distillation and fractional distillation. Fractional distillation mean the different components of the mixture, their boiling point very close each other. Boiling point of different components of mixture very close each other, so we have to use fractional distillation. Very close each other mean different components of mixture, their boiling point difference less than 25 Kelvin. For example, alcohol and water will boil 100 degrees Celsius, alcohol will boil 70 degrees Celsius, and water will boil around 100 degrees Celsius. So their boiling point difference around 25 Kelvin. Okay, around 25 Kelvin. So we can use fractional distillation. Also another example, acetone and water, their boiling point difference very close each other. Okay, their boiling point difference, their boiling points are very close each other, not big difference. Okay, big difference mean different components of mixture, their boiling point big difference, then we have to use simple distillation. Okay, in simple distillation, example for simple distillation, seawater. We want to obtain pure water from seawater. So we will heat very strongly, water will change to water vapor, and pure water we can collect after condensation. Okay, this is simple distillation. Also all impurities will stay on the distillation flask. So their boiling point difference much bigger. So we have to use simple distillation. Acetone in water, alcohol in water, or you want to separate oxygen and nitrogen from air. So we have to liquefy air. We have to change gaseous air into liquid state air. Then we will warm this mixture. We can separate oxygen and nitrogen. Okay, liquid air, we can separate oxygen and nitrogen. Their boiling point very close each other. So we have to say it is fractional distillation. Okay, in fractional distillation there is one more apparatus over here. Okay, fractionating column. You can see in this figure fractionating column, also glass beads over there to increase their separation. Okay, for simple distillation you can see only this figure. You can see only this one. There is no fractionating column and glass beads in simple distillation. Only fractional distillation you can see fractionating column and glass beads to increase their separation. Okay, next one we have to discuss here, separation of different gases from air. Okay, to separate different gases from air, we know gas it is air, it is gaseous state. We have to convert gaseous air into liquid air. We have to convert gaseous air into liquid state, applying very high pressure and very low temperature. Reduce temperature and apply very high pressure. We can change air in gaseous state to air in liquid state. Look here when you apply high pressure and very low temperature, here oxygen will change to liquid state very fast, minus 183. Okay, but you have to reduce temperature very low to convert nitrogen into liquid state. Okay, so here first oxygen will change to liquid state, then argon, then nitrogen. This is the order, different gas which change to liquid state. Okay, we have to reduce temperature very low to change nitrogen to liquid state. After that we have to warm this mixture. After warming again, oxygen will change to gaseous state, first. Oxygen will change to gaseous state first, then argon, then nitrogen, because nitrogen at a very low temperature and we have to warm little bit, we have to warm more to change to gaseous state. So here you remember nitrogen will change to liquid state very last. Also nitrogen will change to a gaseous state also last. Okay, but oxygen will change to liquid state first. Also oxygen will change to gaseous state first, because of here lower temperature oxygen change to liquid state. At lower temperature also we can change to oxygen in gaseous state. So here this method is called a fractional distillation. Fractional distillation, why we use here fractional distillation? Because different components of mixture, their boiling point close each other, not much difference in their boiling point. So we have to say here this process is fractional distillation. Okay, and also here we have to apply very high pressure and very low temperature, then only air gaseous state change to air in liquid state. Clear? Okay, next one we have to discuss here purification of copper sulfate. Okay, purification of copper sulfate. To purify copper sulfate from impure copper sulfate, we will use crystallization. We will use the method crystallization. This is another method to purify sample, to purify mixture. Crystallization. See this video, I am giving you one video related to crystallization. So using this video you can understand here crystallization method. Okay, so here different methods for crystallization. Here we have to dissolve, we have impure copper sulfate. Okay, take this impure copper sulfate and add into water, shake well. Okay, and copper sulfate will be dissolved in the water. Separate or remove undissolved impurities by filtration. Take out impure copper sulfate sample, add into water, shake well. Copper sulfate will be dissolved in water. Remove undissolved impurities by filtration. Warm this mixture. After filtration we will get filtrate. We will get the mixture which contain dissolved copper sulfate. Warm this mixture to get saturated solution. After warming, some water will be evaporate out and we will get saturated solution. Okay, saturated solution, we discussed the previous video, saturated solution. Okay, so this saturated solution, take out this saturated solution and cool this saturated warm solution slowly. After that we can see copper sulfate crystals are formed. Copper sulfate crystals are formed. Take out the copper sulfate crystals. You can take out this by filtration. Okay, so these are the different methods for crystallization. Okay, dissolve impure copper sulfate in water, remove undissolved copper sulfate by filtration, evaporate the filtrate to get saturated solution. Then cool the saturated solution slowly in room temperature, and we can see crystals of copper sulfate formed in saturated solution. Take out this copper sulfate crystals by filtration. Okay, and these are the different methods of crystallization. Next one, we have to understand here applications of crystallization. What are the different applications? Here, purification of salt from seawater. Purification of salt from seawater we can purify by crystallization. And another application, separation of alum. Separation of crystals of alum from impure sample. We can separate it by crystallization. These are the different applications. Clear? Okay, next one we have to discuss here purification of water. Next one we have to discuss here purification of water. To purify water, there are 4 different steps to purify water. Okay, first one, simple hand picking method. Simple hand picking method, sedimentation, filtration, chlorination. These are the different methods to purify water. Water kept in a reservoir. Water kept in a large tank. Okay, it contains solid impurities. It contains big solid impurities like stone, leaf. This can remove by hand, by simple hand picking method. Okay, next one, sedimentation. Water which contain, after sedimentation, again water which contains small impurities we cannot remove by hand picking. We cannot remove by simple hand picking method. This type of impurities can be removed by sedimentation. Sedimentation means after removing big solid impurities, we will add some setting agent. We will add some setting agent. We will add some chemicals such as aluminium sulfate. We will add some chemicals like aluminium sulfate into water. Then shake well. All small impurities will be settled down. All small impurities will be settled down. Okay, this method is called, this step is sedimentation. After sedimentation, we have to conduct filtration. We will pass water through a sand bed, thick sand. Okay, so we will pass water with small impurities through sand bed. Okay, all small impurities will stay on the surface of sand. Pure water will, you can collect pure water from down part of this filter. Okay, we will obtain filtrate, but all small impurities will stay on the surface of sand. This method is filtration. For filtration, we will use a big thick sand because we have much more amount of water. We will purify water from river or large reservoir, large tank. Okay, so large quantity of water we have to purify here, so we have to use this method. After that, last step to purify water, chlorination. We will pass chlorine gas. We will pass chlorine gas to after filtration. We will pass chlorine gas through the filtrate. We will pass chlorine gas. This chlorine gas, it helps to kill germs and bacteria. It helps to kill germs and bacteria. That's why we will do here chlorination. So these are the different steps to purify water. Simple hand picking method. Then sedimentation. Remember here aluminium sulfate used as sedimentation. Aluminium sulfate used as setting agent. Okay, simple hand picking method, sedimentation, filtration, chlorination. Okay, next one we have to discuss here physical change and chemical change. Okay, physical change and chemical change. Melting, boiling, freezing, sublimation, condensation. This type of change we discussed in first chapter. Melting, example, ice changed to water. Water changed to water vapor. You know, ice water, water vapor, all these case they are chemically not changed. Always they are H2O. H2O in liquid state, H2O in solid state, H2O in gaseous state. Okay, chemically no change. Only physical state, the state of matter changed, but chemically no change. Such type of changes are called physical change. Physical change means no new substance formed, not new substance not formed at all. Okay, only the state of matter change. Such changes are called physical change. For example, melting of water, melting of ice, boiling of water, freezing of water. Always the state of matter change, but chemically no change. Also, new substance not forming in physical change. Okay, example here I told you, boiling of water, melting of ice. Also cutting of trees. You cut trees into small pieces, new substance not formed. Okay, there is no states of matter. Even you cut tree, big piece of wood changes small pieces, solid state, but state of matter not changing, even it is physical change. Okay, before cutting it is wood, after cutting also it is wood, not new substance formed. So it is physical change. Also you remember here, mixtures are formed by physical change. Mixture, for example, salt in water. You dissolve salt in water, sugar in water. So all these are formed by physical change. Okay, mixtures are formed by physical change. So physical change means change by which no new substance formed, also no chemical reaction. Clear? After that, we have to remember here, we have to discuss here chemical change. Chemical change means opposite of physical change. Chemical change means new substance formed. Okay, also after chemical reaction, chemical composition will be changed. For example, burning of wood. Wood after burning, it will change to ash and something other new substance are formed. So it is chemical change. Burning of wood, burning of paper, burning of fuels, all these are example for chemical change. Okay, and another thing, something reacting with the acid, metal react with the acid. Okay, zinc reacted with acid or calcium reacted with the acid. Also, these are example for chemical change. Chemical reaction means new substance will be formed. There will be chemical reaction. Also, compounds, also pure substance are formed by chemical change. We discussed mixtures are formed by physical change, but mixture mean impure substance. Impure substance are formed by physical change, but here pure substance, compounds, elements, these are pure substance. Pure substance are formed by chemical change. Okay, so here we discuss physical change. Okay, physical change means change. There is no chemical composition change. Also, there is no chemical reaction, no new substance formed. Boiling, melting, freezing, cutting of trees, these are example for physical change. Then chemical change. Chemical change means new substance will be formed. There will be chemical composition change. Okay, pure substance are formed by chemical change. Okay, burning of fuels, burning of paper, also metals react with the acid. These are example for chemical change. Burning of candle, you know candle wax, it is solid state. When you burn this, it will melt, it will change to liquid state. So solid change to liquid state, there is physical change. Also it is burning of candle, so also there is vapor is formed, new substance formed, so it is chemical change also. So burning of candle, both physical change and chemical change. Next one, we have to discuss here classification of substance. We can classify substance. There are two different types of substance, pure substance and impure substance. Impure substance already we discussed. Impure substance are mixtures. Mixtures are impure substance. There are three different types of impure substance: solution, suspension and colloid. We discussed more details about this. We discussed already impure substance. Now we have to discuss here pure substance. Pure substance we can classify. There are two different types of pure substance: elements and compounds. Elements and compounds, these are different type of pure substance. Elements means substance which contain only one type of atoms. Substance which contain not one atom. Substance which contain only one type of atoms, that is elements. Example, you take one gold bar. Imagine this made of gold. So only gold atom here. So this is element. Imagine this room contain only oxygen gas. So here only oxygen atoms. So this is element. Okay, so elements mean only one type of atoms, that is element. Okay, next one, compound. Compound means substance which contain two or more different atoms chemically joined together. Example, water. Water is a compound. There is two different atoms, hydrogen and oxygen, chemically joined together. It is compound. It is important to say chemically joined together. You take one cylinder, you just mix hydrogen and oxygen. There is no any chemical bond between hydrogen and oxygen. Just mix hydrogen and oxygen. So you cannot say it is chemical, you cannot say it is compound, it is mixture. Hydrogen and oxygen chemically joined together, then we have to say it is compound. Okay, so compound means two or more different atoms chemically joined together. It is compound. H2O, it is compound. Glucose, C6H12O6, carbon, hydrogen, oxygen, different atoms chemically joined together. It is compound. So this is element and compound. Elements and compounds are example for pure substance. Elements, again we can classify metal and non-metal. Metals, silver, gold, platinum, iron, copper. These are examples for metals. Non-metals, carbon, sulfur, nitrogen, oxygen, hydrogen. This type of elements are non-metals. So elements you can classify metals and non-metals. Okay. You know metals like iron, silver, gold, platinum. These are metals. Metals are very hard. They are shiny. They are sonorous. Sonorous means metals produce sound. When you put down metals, it produces sound. Or you beat two metals together, it produces sound. So you can say it is sonorous. Metals are sonorous. Okay, metals are shiny. Metals are good conductor of heat and electricity. These are the some properties of metals. But generally, non-metals are poor conductor of electricity and heat, except carbon. Carbon, it is good conductor of electricity. Carbon, graphite, it is good conductor of electricity. But except carbon, generally other non-metals are poor conductor of electricity. Okay, they are dull, they are not shiny, they do not produce sound, they are not sonorous. These are the general properties of metals and non-metals. We will study more details about this. Later. Okay, so here you just understand few properties of metals and non-metals. I told you compounds and mixture. Compounds are pure substance. Compounds are pure substance, compounds which contain two or more different elements chemically joined together. Compounds are formed by chemical reaction. Compounds are formed by chemical reaction. It is also, it is compound. For example, H2O, 2 hydrogen and 1 oxygen. So they have fixed composition. Their components must be fixed. H2O, two hydrogen and oxygen. If you put H2O2, it is not water. So in compound, their different elements are fixed. Different components of compounds are fixed. Okay, and these compounds are formed by chemical reaction. It is pure substance. Okay, different components of compounds you cannot separate by physical method. You cannot separate hydrogen and oxygen simple physical method, like we discuss many methods, filtration, distillation, chromatography. This type of physical method you cannot separate compound. Okay, these are the things we discussed in compound. Compounds are formed by chemical reaction. Okay, and new substance formed here. Okay, fixed composition here. Also different constituents we cannot separate by filtration. But here mixture it is impure substance. Mixtures are formed by simple mixing without chemical reaction. No new substance formed. Different components of mixtures can be separated by physical method. For example, salt in water, it is mixture. We can separate by evaporation. Okay, new substance not formed. Okay, also here no fixed composition. You take 1 glass water, put 1 teaspoon sugar, shake well, it is mixture. Also you take 1 glass water, put 2 teaspoons sugar. Okay, so these are the things we discuss about mixture. Mixtures are formed without chemical reaction by simple mixing. No new substance formed. Okay, there is no fixed composition. Also it can be separated by physical method, filtration, distillation, or this type of method we can use to separate mixture. So these are the things we have to discuss over here. Clear?